Alright, we've got the last couple problems on this notes page. After 24 days, 2 milligrams of an original 128 milligram sample remain. What is the half-life of the sample? So again, we're going to go at this from the standpoint of dissecting this equation, making it work for us, but then we're going to go back and look at it with the table and think, okay, how could we have figured this out in another way? So after 24 days, 2 milligrams of an original 128 milligram sample remains. So that means 2 is our final amount. 128 is what we began with initially. We have this 1/2, and then 24 is the amount of time that has passed, but we don't know the value of the half-life. So H is what we are solving for. Now I'm going to tackle this the same way we tackled some of those problems that you had on a recent homework. I'm going to divide. I don't absolutely have to divide, but it's going to make our problem a little bit easier. When I divide by 1,
on the left side I end up getting 1/64. And on the right side, right, these cancel out, I'm left with 1/2 to the power 24 divided by h. Now when I look at that problem, I notice 64 and 1/2 are powers of the same base. Specifically, they're both powers of 2, so 1/64 can be written as 2 to the negative 6th power. If you're not sure about that, you take out your calculator and you type it in, and you go 2 to the power negative 6. Oh, look, yay, it's 1/64, so negative 6 it is. And then this is equal to 2 to the negative 1st to the power 24 over h. So then I'm going to simplify this exponent and then equate those exponents. 2 to the negative 6th power is equal to 2 to the negative 24 divided by h, right? Because negative 1 times that makes that. I'm going to set these exponents equal to each other, because since they have the same base, we can equate the exponents and solve the problem. Negative 6 equals negative 24 divided by h. There's a lot of ways you could do this. You could use cross products. You could just reason it out. I'm going to multiply both sides by h. And then that's going to give me negative 6h is equal to negative 24. Divide both sides by negative 6. And I end up with an h value equal to 4. So the half-life, 4 days. That is a half-life for this function, for this particular sample of something. Now let's think about how this would work in terms of just reasoning it out. If you didn't have an equation, or you forgot the equation, or they didn't give you an equation, let's just think about how this would work. Setting up a table like I did on the previous problem, where again we're going to put the days here, and we're going to put the amount remaining here. Now when we started out at day 0, we had that 128. And we don't know exactly how many days passed, but at the end of those days, at 24 days, we ended up with 2. So since we're working with half-lives, I don't know exactly how many half-lives are going to happen, but let's see how many halves we have to do in order to get down to 2. From 128, if I divide it in half, right, just like we divided this in half to get the successive values, divided in half, it gets me 64. That value divided in half is going to take me to the number 32. In half again, 16. In half again, 8. In half again, 4, and then one more process of halving it, and we get 2. Now, we need to figure out what amount of, like what all these values would be, so that that difference will give us our half-life. Because that difference at 100 here, that was our half-life here, same concept here.
Now it turns out that if I try 2, right, from 0 to 2 to 4 to 6 to 8, 10, 12. Okay, 2 didn't work. 3, 6, 9, 12, 18, 21. Okay, 3 didn't work. What other things go into 24? Let's try 4, counting by 4s. 4, and then 8, and then 12. Because notice, these are all going up by the same amount, so these all need to go up by the same amount. For 8, 12, I got a 16, and then a 20, and then 24, which is where we wanted to land. So our half-life then is the difference between each of those x values. And we see that our half-life is 4. So again, the equation works, and if you can sometimes have values that work out such that you can just sort of fiddle with the numbers and get your answer to be there nicely as well. Last question, problem 6. Again, we're going to go at it with from the standpoint of the equation. How much time is required for a sample of H3 to lose 75% of its radioactivity? Assume the half-life of, let's assume that these are the same thing, is 12 years. I don't think they're the same thing, but we're going to assume that. All right. If I'm losing 75%, that means what remains is 25%. So even though they don't give us a specific quantity, we're going to assume we're going to assume that our initial starting value is 100%. Okay, so if that's the case, then I'm just going to write this out. All right. My initial value is 100%, so I'm going to put 100. Final value is 25%. I have a 1/2. I don't know what the time is, but I'm going to divide by that half-life of 12. Same process as before. I'm going to move this 100 to the other side through division. Then it's going to be another problem where we're going to end up equating exponents. 25 over 100 is the same as 1/4. Now, this is really 2 to the negative second, and this is really 2 to the negative first, to the t divided by 12. So then 2 to the negative second equals 2 to the negative t over 12. Take those exponents, set them equal. Negative 2 equals negative t divided by 12. Multiply both sides by, you can just multiply by negative 12 and be done with it, but I want this to be easy to see, so I get negative 24 equals negative t, so then that implies that t is equal to 24 years. Again, thinking about this in the context of a table, if I am starting out with 100%, at time 0, and I'm trying to get down to 25%, let's think about what we know. From 100%, it's going to go down by half, so it's going to go down to 50. Down by half again, and it's going to go down to 25. That was our goal. Now we needed to know what was the time length here. Well, since we're told that the half-life is 12 years, it took 12 years for it to get to 50, and then 12 more years takes us to 24 years. Got us that value. Okay, so you can reason it out with the table, or you can chug through those numbers and play with the exponents, and it's a very beautiful thing.